Hello everyone. I want to present to you today a machine learning project which I did. The whole reason why I do this is you will get an overview how I worked in the console with AWS, which notebook I used or how the Jupyter Notebook is structured, which data I used. I show also a little bit of the coding, and then we will see also how I access a website, where I run the application in the end, so that it is used also in a normal day process. So what we first do is, as you can see, we are here in the AWS console. I can use also Jupyter Notebook in another environment like Anaconda or something else, but mostly I use now SageMaker. So first we can exit it here, and then let's go into it. As you know, when you would run a SageMaker on a notebook or notebooks, you have to start then in motion. So normally you go here and say then start. I did this already in preparation of the session here, so it's already running and in service. And then we come to my projects, and here we have the hard disease project. I opened this already here, and let's go through it. So what we will do is we will take in some data. We will then make some machine learning analysis with it, build then also the models, and then try to predict even if a patient has heart disease or not. So first what we've learned is that we do here a classification model. So what we first do, mostly I will write, okay, what's my problem? What is this all about? What is the data which I use, and so on. And the workflow looks then like this. So we do the problem definition, we look a little bit in the data, we check the evaluation, we will check also the features, we will model the stuff, and then we do some experiments in the end with grid search CV and try to improve our model on the hyperparameters. So next step is then, okay, how is our data looking? I'm not a doctor, so mostly I'm not so much familiar even with age and sex, for instance, with the chest pain types. So what I did here was to write a short dictionary on what are the features all about, that someone who is not familiar with the stuff can easily also type in or use in the end the model. Then we start with first importing our libraries. So as you can see, sklearn do for the modeling. Then we have the train test splits, we have the cross validation, we do in the end precision scores, confusion matrix, and the normal basic libraries like pandas, numpy, matplotlib, difficult word, pyplot, seaborn. So when I run the cell, as you can see here, it's a function, and then it would tell me, okay, all is imported and we can use the data. As I told you, I will do this all in AWS. So when you normally do this in Anaconda, you have your file somewhere else. But for me, I read it from an S3 bucket, which I created before, and there I put my data. This one is here, heartdisease.csv. Some warnings we can ignore here. And what I did mostly is that I will then shortly show with .hat, for instance 5, if the data is correctly loaded, some description, some value counts, and what is the proportion, for instance, of the heart disease or not. So our target value in the end, as we do a classification, is even a 1 or 0, as it is a binary one. And I want to know upfront already in the data how many how many patients had heart disease or not. So we call then the function, and as you can see here, so we have here our columns and our target values. We have here the first 5 rows of our data. Here we have with the describe function already some excess data. So, okay, what's the standard deviation, what's the mean, what's the max, and so on, the minimum value of it. Then we have overall here 165 with target 1, so this means they have already heart disease, and 138 would be they would not have, which is a 54 by 45.54% split. Difficult word. This is the original data. So what I do mostly is then I will copy it into the df temp so that I even don't touch the original data and do not so much stuff on it and then don't have it anymore. What we are next doing is we will check if we have missing values. If there is something, they would say it, and also which data types I have, because you all know machine learning means I need numbers, not any strings, and if so, I have to transform them. So you have there many variations, but as you can see here, we have no missing values, so and all have a numeric format or data type, so we can work for it. If it would be not, we would drop it, and if it would be string, I have here also a short function with a one-hot encoding inside. We don't need it here, but if I would work with this one also on another project and I have another data frame, I can easily use this one here also as an example, as a template, and then I would do here also the one-hot encoding with it. Okay, then. So evaluation, we say, okay, we want to have a model with 85% point accuracy. And what we do in the next step is we look in our features and we do some EDA on it. So first, yeah, what we can do, we will graph the stuff, yeah? And this is what I did here. So we have here the sex, even if it's female or male, and how many of these were without heart disease and with heart disease. And so you can see 114 of the males were without heart disease and 93 with it. So easily you can, when you do with Seaborn some graphs up front, you became like a POC, like a SME on the data itself. You have to know which also which types of data it is, like correlations you have to know. Overall, you should know your data, and this is what it's all about. You do this best with graphs, or even when you present then the machine learning projects to a colleague or to a customer, do this best with graphs. So we have here the first one, and the second one is a little bit more. This shows then the distribution. So it's like a normalized normal distribution. So we see here the age on the male and age also of the woman. And then it shows how many have heart disease or not. So we see here, for instance, in the column with the 55 or something, 50 around, many of the women had already heart disease, and the same nearly also for the men. And when we would look at the graphs, it looks nearly like a normal distribution. The next one, what we do is the correlation matrix. So the coding itself is like, okay, I will not have here only the graph. I will zoom here a little bit out. It's possible. So we have here only the down part, and let us a little bit look inside for which I don't know the correlation so much. So it shows which features has the most important impact on another feature. Mostly we are interested in the which features has the most important influence on the target variable, and then we will see here, for instance, target variable. So CP, the age, the sex, Talach, slope. So these are features which had a high impact. Also here, Exang, old peak, high impact in the end on the result. So this can already, the correlation metrics can already show you, okay, which features are very important, even though when you do other projects where you have up to 200 or 300 features, try to drop some that the model takes not too long to calculate, so you can best work with it. Okay, then I show here only the highest correlation, so this sometimes is not so good readable, even if you would do something like a sentence here up front to say the most important things. But with this one also, it's probably a little bit better readable. Okay, as I told you, so Old Speak, Exang, they have a high impact, and also CP and Talach. And then when we know the correlations and we present it, I think we can go now to the modeling. So what I did was, as we have a classification binary problem, we take here 3 models. The first one is the logistic regression model. The next one is the k-nearest neighbor and the random forest model. As you can see, we did a train test split. So we split the data into a training and a test and shuffled them. And yeah, after fitting, which is mostly here, we get the following results. So first of all, you can see here our data was split into 242 Y train and 61 Y test, X train 242 and 61 columns of X test. And here we have the first results. Let me zoom in again. So 86% was with logistic regression, the prediction correct, 68% with k-nearest neighbor, and random forest made the 83%. With the accuracy, I mean, not here like, which we come later to some other, so cross-validation. So this is the first glimpse on how the model itself performed. So then, checking the underlying hyperparameters. So as you know all, okay, we did some intake of some hyperparameters. So which one gets which, and we see here, for instance, which in the logistic regression hyperparameters, which we are using k-nearest neighbor and also random forest. So max features, where's here the, and estimators, yes, for instance 100. Random state 42. So these are some of the hyperparameters which we took in. And when we know our hyperparameters, and you saw already that we have some, I would say with 86% and 85% already something to work with, we will now tune them. I took two tuning mechanisms. So the first one is the randomized search CV. This I did with the logistic regression, k-nearest neighbor, and also random forest. And as you can see, after randomized search CV was done, we have 82%, 64 and 81%. So slightly a little bit even worse. And then we will go now on and take only the 2 best models, so logistic regression and the forest classifier, and do the grid search. The grid search took here a while, so what I did, and you can see it here in a dictionary, so we have here up to 200, something like this, 200 iterations also for random forest, something around this. And let us have here also then the precision scores. So we would have then an overview how the grid search was working, and you can see here that there was a lot of calculations. I do this on my Chromebook, so took a while, but no problem, as we are using SageMaker. And then we have here the result. So after the grid search CV, our accuracy improved on the logistic regression again to 88.5%, and the random forest on 85.2%. Let us have then in the end a short confusion matrix. But I already can point out 88.5% on a logistic regression. I think this is the model which we can go for it. Depending all in all on how much data I have. So here we had around 320 or something data sets. That's not many. If we would have more, you could do also longer randomized search CVs. You can do the grid search longer to improve your model even further. It's an iterative process. But for this example, I think it would make a good sense to go with it. And as you can see, our logistic regression, let us take your true label. So 29 times it was correctly predicted, 3 times not. And on the random forest, 28 times correct, 4 times not correct. So let's see then also the probabilities. I printed them here a little bit. I think with the probabilities to work also then in the production or when somebody is using it on a daily basis is good, as we can then see, okay, how it's going on. And does this really make sense? I'm not a doctor, like I said, but when I would use it as a doctor, why not the machine give me already a hint, give me already a probability to work with, and then we will see from there. Okay, good. I think we covered here already a lot. Let's go now into the logistic regression, so predicted probabilities. So what we see here is how often the model was nearly to 1. So, okay, here the model is quite sure that it is heart disease. And here it was also 18 times quite sure it is not. And in the middle we see we don't have here so much, but some outliers are here. So 2 times it was, I would say, at 50% nearly sure it is heart disease. So everything what is above 0.5 goes into the heart disease, and everything what is below 0.5 goes into the 0 target value, which means no heart disease. But I think overall the machine was here on some points quite confident that it is, and also quite confident on the lower end that it's no heart disease. Just to show. Okay. Last one. Feature importance, same as the correlation metrics, but we see, okay, the even the sex, which is not so much expected, but it is the tal, the exang. So these are features which are very important for the prediction of the target value. And then when we have this, I think we have then our model. And we saved the model here with pickle. So I imported pickle and saved it to my S3 bucket. And how we go on now from here. So this could be in a small of a presentation like, but how you would use it. Did everyone then have a Jupyter Notebook open? Did you present it as a file? So what we can do is we will launch something in AWS, and what we can do for it, we will go shortly to a friend of ours, which is a machine model. So you could, for instance, prepare some files, so an app.py, an index.html. The index.html is for the website itself, how it's structured. The app.py has the other information, how you can then access the EC2 instance, and there's 3 buckets. So what I did, I have then also EC2 instance. I access the EC2 instance. I moved in there the app files and also these 2 files. I run then the stuff with gunicorn. And let us have a look how it could be done. So a little bit more, let us go back to SageMaker. And first we started in a VPC. So first you create, so I did it with a VPC. There are way more other models how you can use it, but I want to have it in a VPC. So let us wait here shortly. So I launched a VPC. In this one, I created some public and a private subnet. I have the routing tables. I have an internet gateway, and with this, I can access the VPC also from outside. Then we go to EC2. So in the EC2, let us shortly load this. Sorry for this. We're back. Here we already have some information on it. Just loading. Oh, come on. Give it some time. Okay, here's my instance. It is already running, and in the end, in the AWS instance, which could be a T3 micro, it's all enough for this. I moved in there the files. It is running, and as long as it's running, we can access the web page. So what I did then is I go back to my terminal here. I'll have it shortly. So I connected to the EC2. I set then the command sudo gunicorn --bind and then app.app. Then it's starting. And what we now can do is to create something like this. Make dreamy, predict heart disease. Simple. Everyone knows Grey's Anatomy. So I have here the web page. And let's try some real stuff. So our patient is 63. It's a male. He has a chest pain type of 2. Resting blood is 150. So it already can give you some hints what could be. Cholesterol 261. No blood sugar. We have here nothing to note. 2. Heart rate 187. Exon 1. Stress during unhealthy, so 3.6. 2. So, as I'm not a doctor, I think what we did here is try to move some of the stuff inside that you know what it is, as it can be even done then by a nurse. But normally, okay, a doctor knows a little bit what could be here something. Okay, we gave now the model all the information. And as I told you, it can predict here something. So let us have, so actually the model predicted here that it's no heart disease. Probability is 1.03% that it even has heart disease. So this could be then in the out in the world in production, how you can then access the stuff. Okay, so then I hope you liked the video. I have to admit that this one was my, get it first here on the top. I hope you liked the video. I hope you had the first glimpse. For me, it was very fun. It's my first larger project which I did, and I wanted to present it to you here in this short video. If you want to see more content, no problem. Write me a comment. Please like and subscribe. And then see you next time for the next big project. Bye bye.